However, I'm now going to go to the next page, and I'm leaving now that, and I'm going to get now to some technical stuff, and this page is a pretty picture, and basically the question is, how does a laser even work? How do you make one? And I remember when I was in physics class, when I was back in college, I'm embarrassed to say back in the 1970s, I saw one of these operated. And back then, they were still a pretty cool thing. I mean, they were not by any means common. Now they're very common, but even back in the 70s, they were somewhat mysterious, and labs had them in physics departments, but you didn't have laser pointers. You didn't have other things I'll talk about. So how does it work? Well, basically, this purple thing you see here is a tube, and basically, the tube is filled with what they call a gain medium, and what that is just a material. You could put a gas in there, like carbon dioxide. You could put a solid material in there, like ruby crystals, or you could put other things in there as too. But let's assume it's a gas. And if you want to think of something simple, just imagine that it's carbon dioxide. So you put that in there, and on one end of the tube on both ends of the tube are mirrors. They're mirrors which reflect light back and forth, back and forth, back and forth. So you can see that I labeled that 3 and 4 are reflectors. And the reflector on the right, labeled 4, has the property that it's not only a reflector, but it does allow light to get out if it gets high enough. If the light gets enough energy on it, the light can escape, and it escapes through, and that's going to be your laser light. So the way this works is 2, if you see 2 there, 2 is called laser pumping energy. And what you do is you put some energy on the gas, and the energy could be as simple as an electrical current. You plug in electrical current, and the current goes in the gas, and what it does is it excites the gas. And it does what I described at the beginning of my presentation. It makes all the electrons in that gas jump to a higher energy level, and when they jump and they go back down to the lower level, they give off a pulse of radiation or light. And if they all do it at the same time, you get a pulse. And the pulse comes out of the mirror on the right, mirror number 4. But to get the necessary energy to make the pulse, what happens is as you turn the current on and the current goes in the gas, the light that's made from the energy level jumping of the electrons, it goes back and forth between the two mirrors. It goes back and forth. And as it's going back and forth, it's further exciting the electrons, and they're getting more and more energy built up until finally there's so much energy that the mirror on the right, mirror 4, can't reflect it anymore, and it comes firing out as a laser beam, and that's how you get a laser beam. So if I was there physically right now, I'd say, are there any questions? But I think this sort of shows how it works. So now I'm going to go to what kind of, how do lasers work? What kind of beam do you get? So I'm now on the next slide. It's called different frequencies of lasers. And basically lasers, when they come firing out of that tube, they can be emitted as many different things. You could actually see the beam in some cases. It's visible light, and you can see on the second item on the slide, visible light near the end. So you can see the beam. The beam could be red, it could be green, and I'll show some pictures of those. On the other hand, it doesn't have to be visible light. The beam could be microwaves, which you all know from your cell phones. It could be a microwave. You can't see microwaves. They're invisible, so you could have an invisible beam coming out. It could be radio waves. That you've all heard radios, obviously. It could be radio waves coming out. Again, you can't see a radio wave. It could be infrared. You can't see that either. And it could be very, very, very energetic, high-energy X-rays. And if you get X-rays coming out of, if you have a laser which makes X-rays, you better get out of the way because it's going to be pretty dangerous. But the point is that you can have all different kinds of radiation as laser beams, and it's called electromagnetic radiation. Electromagnetic radiation is just radiation that exists in the universe, and it comes in these different forms: infrared, X-ray, microwave, visible light, radio. And those forms depend on how they oscillate. They oscillate up and down like waves you see in the ocean, and the different rates of oscillation oscillation give you different kinds of beams. So I'm going to show you what those are. If you look at this chart here, the next slide, the vertical axis has labels on it: gamma rays, X-rays, ultraviolet, visible, infrared, microwaves, radio, and TV. And the visible one on the right, you see it opens up and you see the different colors of the spectrum that we can see. But the visible one, as you can see, is a very tiny bit of the entire spectrum. So most of electromagnetic radiation is actually not what we can see with our eyes. It's all invisible. And the higher up you go, the more energy that's involved. So you have gamma rays, which are very dangerous. They're emitted when you have nuclear explosions. And if you get hit by a gamma ray, you can get zapped and you're going to get cancer or die. X-rays, as you know, are very dangerous too. Any event, X-rays, lasers can be emitted in all these things. And luckily, the ones that have a lot of applications get emitted invisible, so you can see them, and they're pretty cool looking. So this is how this works. And the frequency, the number of times it oscillates, more or less, is on the left-hand side. I'm not going to go through that, but you see all the different numbers, and that's all that's important. So anyhow, the laser can be, you can have an X-ray laser, ultraviolet laser, visible, infrared, etc. Okay, now, when I said you have, in that tube, I said you could put different things. What kind of things can you put in there? Well, I mentioned, when you want the gain medium, which goes in the tube, that's what's responsible for getting your laser beam, because when you put energy on that, it makes the laser light. So what kind of gas can you put in there if you want to put a gas? Well, you could put helium neon. That's a very popular one. Carbon dioxide, as I put there, is another one. And there's many other gases you can put in that I didn't list. There's another kind of lasers that use chemicals. The tube actually has chemicals in it in a liquid mixture. And I just put down a popular one they put in lasers. Hydrogen fluoride now hydrogen fluoride is in there in the tube, and when you put the electric current on it or another form of energy, what you can do is the hydrogen fluoride changes, and the byproducts are going to be, and I'll just say this for the chemists in the audience, will be ethylene and nitrogen trifluoride. So chemical lasers are more complicated. They have these fluids in the tube, and then when you zap them, when you put energy in there, they make byproducts. But they'll also make a laser beam. You also have what's called solid-state lasers, where in the tube you put crystals. And for example, you could put rubies in there. And I'll show you a picture of a ruby shortly. They tend to get very high-powered lasers. And another kind of laser is called a photonic crystal laser. And those are lasers where you have a material. It's a crystalline material, and it's has a tiny structure to it. The crystal has little tiny things in it which give rise to what they call a periodic optical microstructure. So it's a pattern that repeats in the crystalline structure, but it's a pattern due to little tiny structures. And opal has it, and you can see those structures in the iridescent color an opal makes. So let me show you an example of that on the next slide. Here's an opal ring. I think it's a ring or it's a bracelet. I can't tell. For the I guess women in the audience who like nice jewelry, this is a nice looking bracelet. But you can see that the surface of the opal has this beautiful iridescent pattern, and those are those periodic microstructures I was talking about. And you can take those kind of material that makes that in the opal, and you can put that in the tube, and that can generate a laser beam. Here is an example of a ruby laser. This is a cool picture. I like this one a lot. You can see on the left a laser beam is coming out of a device, and in that case that's a ruby laser. So the device has in it a ruby crystal, and the ruby crystal is generating the laser beam when you give the ruby crystal some energy, like a current, and out comes the laser beam. And here it is. And like I said, these beams can be quite powerful. in this case, is burning a hole in a razor blade. There's a razor blade to the right, and you can see that it's burning it. So obviously, you don't want to stand in front of this laser, or it would ruin your day. You'd have a hole in yourself, and it wouldn't be too much fun. But I like that picture. The sparks are flying out, and it's really neat. But anyhow, that's an example of a ruby laser. And here's a ruby crystal. For those who like crystals, I just had to show this because this is a beautiful picture, I think, and you can see the deep red ruby color. But it's fascinating to realize that a crystal like this can actually make a laser beam. If you get into lasers, which there's other crystals which can generate lasers too, but rubies, definitely do it. Now, there's one drawback to rubies, which I think everybody in the room knows. Rubies are not cheap. This ruby here is a famous one. I forget the name of it, but it's one of the biggest rubies in the world, and you would have to have many millions of dollars to buy this if you wanted one. But ruby rings are expensive, so they're not cheap stones. So if you want to make a ruby laser, you better have some cash. Okay, now I'm going to get to the fun applications. There are many, many applications for lasers, and as I mentioned, the first working laser wasn't even until 1960. So that's only 50 years ago. That's much older than most of you people there, but in the audience. But 50 years is really not a long time. And these are the different fields that lasers impact: communications, computers, scientific research, measurement, movies, music, the military, possible energy production that's going on right now to make to harness a hydrogen bomb called the fusion reaction, welding and cutting. The medical industry uses it. I'm going to talk about this in a moment. Cool things like holograms, which are three-dimensional pictures that use lasers, printers, optical discs, and simple things like pointers. So it has many, many applications, and it's fair to say that lasers have truly played a role in revolutionizing our society.